properties of cross product. Let's look at the properties of cross product. Properties of vector products. Okay, so what are the properties? So this is how we can compute the properties. Number one, we have that vector product is not commutative. So vector product is not commutative, okay? Not like scalar products. So i.e., what we have is that if you do A cross B is going to be equals to minus B cross A. Okay, so you can see because of the minus, it's not commutative. Okay, and we don't have to prove the results, so it's just it holds. Okay. Number two, for any two vectors A and B, so for any two vectors, after for any two vectors A and B, comma uh, minus B, okay, cross A is equals to A cross B, okay, A cross B, which is equals to B cross minus A. You can see how it goes. So whenever you interchange the vector, it becomes negative. The one you are interchanging becomes negative, okay, and it holds. Okay, so take note of these properties when you see them in question. And then we have the property 3. For for any scalar n, I believe by now you know what a scalar is. For any scalar n, okay, we have that okay, so the scalar is n. We have that n multiplied by A cross B, okay, is the same thing as n multiplied by A cross B, okay, which is the same thing as A cross MB. Okay, so it holds for scalars whenever you are multiplying scalar. And then we have the fourth property. The fourth property is called the distributive law. So for any vector A, B, C, okay, we have that A cross B plus C, A cross B plus C equals to A cross B, okay, plus A cross C. So vector product obeys distributive law. So and we can always apply this property when we are multiplying a vector product. Okay, so another property is that so for any vectors A, B, C, we also have that A cross B minus C, okay, equals to A cross B minus A cross C. Okay, so it's also good. It satisfies the distributive law over addition and subtraction. Okay, and then we have the sixth property. Okay, so if two vectors A and B are parallel or collinear, so we have A and B are parallel or collinear if we can show that if and only if a cross b equals to 0, okay, a cross b equals to 0. So two vectors are parallel or collinear when their cross product is equal to 0. Okay, so those are the results that you should understand, and of course we've shown this result, so this one is no longer new. Okay, that if a cross b is equals to 0, then either a is equals to 0 or b is equals to 0. Okay, so we've shown that several times. Okay, um, or we can also have that a is parallel to b, or a and b are collinear. So that's the conditions. So a cross b equals to 0 depend on whether a equals to 0 or b equals to 0, or a is parallel to b, or a and b are collinear. And these are the 7 properties of vector products that we have. These are the properties. Okay, and then the next one we have is a area of parallelogram. How can we use vector properties to calculate area of parallelogram? So let's assume we have a parallelogram, this parallelogram this way. Okay, let's assume this is what we have, and then we have it this way. So if we draw another broken line here to join this place, and then we have a perpendicular line from here. So if this is a and this is b, so this is c and this is d. So if this is vector b, okay, and this is vector a, so if this is angle theta and this place is right angle, so we can calculate the area of the parallelogram. So the area of this parallelogram is given by area equals to half multiplied by a b, okay, multiplied by dl. So let's use bracket instead of that. Okay, and this is the same thing as half of, so the area of the parallelogram is base times height, half base AB multiplied by DC, right? So DL, so this place is L. So this formula can be written as half AB sine theta. Okay, and then you know that when we talk about this AB, we are talking about A, which is modulus of A, and B is equals to modulus of B. So this is the same thing as saying half A multiplied by B multiplied by sine theta, okay, which is actually equals to A cross B. Okay, so A cross B. So we can use the formula to calculate the area of parallelogram. So therefore, area of parallelogram. So if two adjacent sides of a parallelogram are given as A and B, then the area of parallelogram equals to A cross B. Okay, where A and B where A and B where A and B are two adjacent sides of the parallelogram. So we can use vector cross product to compute the area of parallelogram. We can also use vector cross product to compute the area of triangle. Okay? Area of triangle. Now, how can we use it to compute the area of triangle? Look at, we have a triangle here, and then this joined together this way. So if we have the height of this triangle to be this, okay, so this is the height, and then this is right angle, this is angle theta, so this is vector B, and the base here is vector A. So if this is A, this is B, let's call this point L, and this is C. So we can compute the area of this triangle. So the area is given as half base times height, right? So which is half AB, half AB, okay, half AB times CL, which is the height. Okay, so this is the same thing as half uh, AB sine theta. Okay, so half AB sine theta. And what do we have if we put sine theta there? Let's see what the results we have here. Okay, yep. Okay, sorry, I forgot to put times 2 here. You know, we use triangle here, so this is times 2. By the time we multiply it by 2, we have that. Okay, so that's how we got that. So for triangle, we have half AB sine theta, and this is the same thing as half into modulus of A multiplied by modulus of B multiplied by sine theta. Okay, which is half into A cross B. Okay, so and then we can leave the answer like that. Okay, so basically when we are using the product, you don't need to put absolute value here, so let's just leave it as it is. So let's write just one line of it. Okay, so this is equal to half into A cross B. Okay, so this is area of triangle. So therefore the area of triangle, the area of triangle, the area of triangle uh, whose adjacent sides, the area of triangle ABC, okay, triangle ABC, where AB equals to vector A and AC equals to vector B, implies that area equals to half multiplied by the cross magnitude of the cross product. Okay. So that's how to compute area of triangle. So we can also compute area of area of quadrilaterals. So area of